ओके, लास्ट टाइम हमने ग्रेविटेशन स्टार्ट किया था और आई टॉक्ड अबाउट वेल आई मैंने आपको लॉ ऑफ ग्रेविटेशन मैंने लिखा था बेसिकली एंड फिर हमने कुछ या इनफैक्ट मैंने कुछ कहानियां झाड़ी थी अबाउट ग्रेविटेशन और केपलर्स लॉज के ऊपर हमने थोड़ी सी बात की थी। हमने डिफाइन किया था केपलर्स लॉज को, लेकिन वी डिड नॉट सी सम प्रूफ फॉर दोज लॉज। तो इन टुडेज लेक्चर हम सबसे पहले तो स्टार्ट करेंगे प्रूफ से केपलर्स लॉज के। सो आवर गोल विल बी टू डिराइव केपलर्स लॉज, राइट? तो वेल हम पहले यहाँ पे मैं केपलर्स लॉज लिख देता हूँ। लेट्स सी इफ दिस वर्क्स। मैंने कॉपी तो किए थे, ठीक है, ये आ गए थे ऐसे, right? So this point number 1 is the Kepler's first law, point number 2 is second law, and likewise. So the first law says कि जो planets हैं वो elliptical orbits में move करते हैं sun के around. तो let's prove that. So हमें असल में प्रूफ ये करना है इसके लिए कि अगर gravity is an inverse square law, so by that I just mean कि if the force of gravity is proportional to the inverse of r squared, तो जो ऑर्बिट है ना वो एलिप्टिकल होना चाहिए basically. So let's start from the Newton's second law, which is F is equal to ma, and we know के जो force है from the law of gravitation, we know we can write that force as the force F will be gm m over r squared. We saw this in the last lecture, and it is in a radially inwards direction between the planets, right? तो force तो हमारे पास ये है, ठीक है. What about this acceleration vector? There's a problem with this क्योंकि it is not just the not just the double derivative of this position, double time derivative of this position जो normally acceleration हम लिखते हैं. एक चीज यहाँ पे I would also like to write or mention कि I would be denoting this double time derivative of r as r double dot. So this two dots on that r are just telling you कि जो आपका r का 2 times time derivative है, right? So if I had single dot, so that would just say that there is just one time derivative of r. So because I'll be using this notation abhi right now, so I'd just like to mention that. Well, लेकिन I was telling you कि जो acceleration है वो r double dot नहीं होगी सिर्फ, और उसकी reason ये है because the planet जो है it is moving in a round orbit, और अगर वो round orbit में move कर रहा है तो उसकी जो acceleration है वो inwards भी accelerate कर रहा है. And we know कि if something is moving in that circular motion or circular path, तो हम उसकी जो acceleration है we write it as r omega squared. So ये हमारे पास जो total acceleration होगी basically it would be the sum of this one and this one, right? Okay, तो फिर अगर हम ये सारी चीजें यूज करके न्यूटन्स सेकेंड लॉ को लिखें तो what we would have is, well, we would have r double dot from the usual acceleration vector, and now minus r omega squared. अब ये minus इसलिए है because again it is because of the same reason कि यहाँ हमारे पास यहाँ पे minus क्यों होता है. because the radius vector is actually radially outwards point kar rahi hai. So we have to introduce this negative sign to make sure कि हम attraction की बात कर रहे हैं, so that we are forcing कि हमारी जो vector है वो inwards force की जो है वो point करे, right? And the same reason we have negative sign over here as well, because the acceleration is inwards, right? ठीक है. So this thing would be equal to this force from here, this one. तो ये हमारे पास negative gm m over r squared के बराबर है, right? But अभी भी इस equation हमारे पास ये एक differential equation तो आ तो गई है, so we can like we can solve it, और हम r की equation of motion हमने असल में निकालनी है. Well, let me just point or mention यहाँ पे कि हमारा गोल ये है कि हमने शो करने के ऑर्बिट elliptical होगा. So if we can find the equation of motion for this system, so if that equation of motion, if it represents an equation of any geometrical shape, it could be a circle, it could be a sphere, or an ellipse in our case, so then we can say कि हमारा जो वो path trace करेगा r वो elliptical होगा, or whatever shape we can get from this equation, right? So well, I was just saying कि we cannot solve this differential equation yet, and the reason is कि हमारे पास ये जो omega है, it would be it is not a constant, it's varying as well, because the planet is moving in a round orbit. So we can fix this, and we can do that if we call upon the angular momentum constant. We know that angular momentum is a constant, right? It's because of the conservation of angular momentum. So well, what is my angular momentum? Angular momentum okay, is it is we denote it with L, and it is equal to m r squared omega. So if I use this thing, I can just get rid of omega in the above equation, ये वाली जो है, or I can just do that by if I write omega in terms of this constant L over m r squared, right? Now the next thing is very direct. Is omega की value हम substitute कर देंगे in this equation, and let's do that. So what we get is I can take this thing r double dot, और इसको हम right hand side पे ले जाते हैं, right? और इस वाले को हम इधर ले आते हैं. So I would have minus gm over r squared. No, 1 second. I would have plus gm over r squared and plus r, sorry, what am I doing? इसको हमने उधर लेके जाना है ना, तो ये is equal to, or let's not do this, it's confusing. इसको जैसे है वैसे ही पहले लिख लेते हैं. r double dot minus r l squared over m r squared whole squared, right? And this is equal to negative gm m over r squared, right? Now what I can do is I can, well, move things around, and I can write r double dot is equal to minus gm over r squared plus r times l over mr squared whole squared. And now let's just let's just simplify this a bit more. Minus gm over r squared plus l squared over m squared, or r power 4 होगी, but it would cancel out with this one, so we would be left with r cube, right? ठीक है. Now to solve this this equation, ये जो हमारे पास ये अभी आई है, this differential equation, we will use, well, a trick, right? And that is कि हम सबसे पहले एक substitution करेंगे where we will say u is equal to 1 over r, and we will use the constant nature of angular momentum. Okay, so, well, first of all, we know that angular momentum is, as I wrote above, mr squared omega. And in this now, I'll just use this substitution, क्योंकि अगर मैं u को ऐसे define करूँ, तो I can write r is equal to 1 over u. And then, well, all I have to do is put it in this equation. So I would have L is equal to m over u squared times omega. Now, what is omega? Omega is simply the time rate of change of the, an angle, right? So that I can write down as theta dot. Again, this dot is just saying it is the time derivative, single time derivative of theta, right? So then I can write this angular momentum as m over u squared theta dot. And well, in fact, let me just use this notation, d theta over dt. And from this equation, we can immediately get that L times u squared over m is equal to, well, let's bring this theta as well over here. So we would have d over d theta is equal to d over dt. Now, well, the next step is, we know r is equal to 1 over u. So I can write dr over dt as d over dt 1 over u, right? And if I take this derivative, I would have minus 1 over u squared d du over dt, right? But I know well, I know from this यहाँ पे कि d over dt मेरे पास L u squared over m times d over d theta है. So I can write down dr over dt as minus L over m times du over d theta. Now, in the similar manner, or let's just say if I take the double derivative of this, that is d square r over dt squared, I get minus L squared u squared over m squared d square u over d theta squared. And this is the equation that we were looking for, basically. So if I go back up here, मेरी जो original differential equation है, this one, I'll just substitute this value of r double dot, जो मेरे पास यहाँ से आ रही है, in that equation, and well, we'll play with it a bit more and see what we can have. So let me just make things a bit, well, I'll just copy paste this over here. Okay, हमारे पास सारा कुछ एक जगह पे हो. Yeah, okay. So now if I just substitute this here, what I have is r double dot is simply this thing, which is minus L squared u squared over m squared, right? And times d squared u over d theta squared. And this is equal to negative gm over r squared from here plus L plus L squared. Well, let me just see. यहाँ पे हमारे पास I think U नहीं आएगा, right? So let's just get rid of that. And over here it would be like this, right? And we would have L squared over M squared R cube. Now if I just multiply this with a U, right, the whole equation, I can write it minus L squared U squared over M squared D squared U over D theta squared is equal to minus GM minus GMU squared over R squared. Wait, I'm making a mistake over here. I'm making a mistake. Let me just go back. Right. I figured out. यहाँ पे we would have U. I don't know why I said कि नहीं होगा. We would not do this thing. Let me just write all of this thing once more, right? So we have this equation and we have this equation. So let's just make this substitution. We would have minus L squared U squared over M squared D squared U over D theta squared is equal to minus GM, but we know, okay, 1 over R is U. So if what would be 1 over R squared, it would simply be U squared. So I can write over here, instead of writing this over R squared, I can write U squared. हम अपनी सारी equation को in terms of U लिख रहे हैं and getting rid of the R, right? And then I would have plus L squared over M squared U cube, right? This 1 over R cube would be just U cube, right? Okay. Well, the next step is simple. You can factor U from here, or U squared. You can factor U squared from here. So you would have this thing. And over here, I'll factor out U squared. And I would be left with minus GM plus L squared over M squared times single U, right? And I can get rid of this U squared with this one. And finally, what I am left with is D squared U over D theta squared is equal to G. I am bringing this M also over there. So I would have GM M squared, right? And let's also bring this L over there. So I would have over L minus L squared over, well, this would go away, and we would have even M squared would go away because I'm bringing this M over there. So मेरे पास क्या बचेगा? I would just be left with U, right? Okay, and this is the differential equation. We can clean it up a bit. Clean it up a bit से सिर्फ मतलब कि let's bring this U वाली चीजों को एक साथ ले आते हैं. So we would have plus U is equal to G M squared over L. Now you can simply use mathematic or anything, or you could solve this differential equation and you would have a solution of U, which would be GM M squared over L squared plus A cosine of theta, right? And over here, this thing A is just it's an integration constant, or it is determined by the initial conditions, right? Okay. Now here is the catch कि हमारी जो equation है ellipse की in polar coordinates. So let me write this down. Equation of an ellipse in polar coordinates. So in polars, it is a times 1 minus e squared over r, and it is equal to 1 plus e cos theta. Right, so this thing comes from geometry and I'm not going to derive it. So, but well, you should know that this is the equation of an ellipse. And if I compare this equation with this equation जो अभी हमने derive की है u के लिए, they are equivalent, right? They're equivalent, and so hence we can conclude this thing कि जो हमारा trace करेगी ये हमारी equation ये वाली, it will indeed trace an ellipse, and so the orbit will be elliptical. And so again, if we go back to the first law of Kepler, ये वाला जो है, it is proved, right? We have proved it. Now, before I proceed further, I would like to say that there are many ways in which you can go about these derivations. It's not necessarily कि ये जो एक derivation मैंने use किया to prove the uh, first law of Kepler, or even the second or third जो भी हम करेंगे, there are multiple ways of in which you can do that. There's also called something that is called the Lagrangian and Hamiltonian formalism, और उसमें आप Hamilton's equations और use करके आप ये चीजें prove कर सकते हैं जो भी हम करेंगे, right? So there are multiple ways. I just like to point that out. Okay, so now let's move on to let me write it over here. Let's move on to Kepler's second law. ठीक है, तो Kepler's second law हमें बताता है कि, well, if I go back up here, what does it say? It says that the radius vector from the sun to the planet sweeps out equal areas, right, in equal intervals of time. So for this, we will consider an ellipse first. So let me just draw, or at least try to draw an ellipse. I hope this works. Okay. And let's draw one focus over here, and that's the only one that we would need. तो हम इसको कहते हैं कि we have sun over here, तो हम इस point को S कह देते हैं, right? And let's draw these two radius vectors for these two positions, and let's label this point, let's call it B, and let's call this one A, and let's call this angle between these two vectors, मैं इधर लिख देता हूँ delta theta, right? And so if that's the case, then this क्या हो गया, then this thing would be equal to, इसको भी इधर लिख देते हैं, r delta theta. Of course, in knowing कि ये हमारे पास vectors r's हैं, and this distance would simply be delta r. Or we can write this arc length, or whatever you call it, you can write it as delta S. And yeah, okay. So what we are doing is यहाँ पे we are considering a planet है, and it travels from point A to point B, और वो distance जो है वो travel करता है ये वाला delta S, right? Of course, in some time delta t. So if that's the case, then we can write down the speed of it in its orbit as delta S over delta t. Right now, well, it is यहाँ पे एक चीज important है कि note करें कि I can resolve the velocity into its vector components, right? One of which it will be in the radial direction, जो होगा हमारे पास, let me write here, delta r over delta t, This one is for the radial direction, and in the direction that is perpendicular to the radius from this diagram. तो for that one यहाँ पे इसको ऐसे लिख लेते हैं, perpendicular to the radius वाला जो होगा velocity, that would be r times delta theta over delta t. Right. So, well, if we take, you guys have studied limits in today's lecture of calculus as well. So, if we take a small limit of delta s, or we say that delta s जो है वो 0 को जा रहा है, तो we can write down this radial velocity vr as dr over dt, and we can also write this perpendicular velocity as r times d theta over dt. But we also know that d theta over dt क्या होता है हमारे पास, r times omega हो जाएगा ये, because d theta over dt is omega. Right. Now, now if I look at this diagram, so during the time delta t, जिसमें the planet moves from the point A to B, the area that is swept out is approximately the triangular area, right? The triangle AB and S, the ABS triangle. So for a distance AB जो है, if it's sufficiently small, then this area just tends to that of this long thin triangle, right? ये जो BS, or for I made a mistake, not a mistake, I should have just pointed कि हम इस वाले point को C कह रहे हैं, right? So right, so this triangle BSC, and इसकी जो base है, it is of the length r delta theta, and the height is r, right? From this diagram हमने पहले label कर दिया था. Now we'll just use the
pause and start this from the next session.
Oh yes, I forgot about this. Let's stop over here. फिर आगे continue करते हैं. Let's see.